9.3 on circles, and my guess is a lot of this stuff is going to be review. So if you know it cold and want to kind of pick and choose a little bit for what to write down, what not to write down, I'm fine with that. It's kind of pick and choose. But a lot of it's going to be term kind of stuff, and if you know the terms, there's probably not tons of reason to write it. But this thing here is the Greek letter we call pi, so it's pi is how they phrase it. And that's approximately equal to 3.1 for... Yep. Nice. So a bunch of people know to a bunch of digits. Usually we just round it to 3.14. Your calculator has a pi button. If you use that in your calculations, it'll be more accurate. I'd encourage you to do that even when the book's like, use 3.14 for pi. It just seems kind of weird. Yeah, you'll be close. But it's up to you. If you want to type in 3.14 so your answer matches their answer key, that's fine. But yes, I agree. Okay, I like to look at this as kind of being a God number. There's this natural number called E you'll learn about later on. But it's a number that just kind of keeps showing up in nature. That when you have things that are circle related, whether it's a cone or a circle or a sphere, they're going to use this number pi. And it's a cool number in that it goes on for forever, so far at least. We're a couple million digits, I think, or a bunch of million digits. There's places you can go online. I could try to find it again if you want, where you could type in like a number, like I typed in my phone number, and it checks to see how many times it shows up in the first 2 or first 20 million digits of pi. And like the first time was like at 600-some thousand. You have those 7 numbers in a row. But there's no pattern. It just kind of keeps going on for forever so far. But that's pi. Next thing I want to hit is like the center of the circle. And you could go with like a fancy definition, like the point at which all the points in the circle are the same distance away, you know. But I'm just going to say it's the middle. I defined exactly the way you did, so it's the middle. But when you go to like the definition of a circle, though, a circle is all the points in a plane, so on a flat surface, that are equidistant from a point. That point is going to be the center. The distance from the center to the circle is called the
diameter.
From the center to the points on the circle, radius. So radius. Guess what the next term is going to be? Yeah, diameter. So radius. Radius is what letter? R. Capital or lowercase?
Capital.
Lowercase. I'd encourage you to start learning which ones are like lowercase and capital. Like when we're doing area, base is going to be a lowercase b. Later on we're going to start using a capital B if you haven't done that before now. But radius, that's the distance from the center of the circle to the circle. So distance from the center of, I'm going to start doing this if I can get away with it for a circle, just a circle with a dot in the middle, to the circle.
I did diameter.
And then I just wrote circle. But if you wanted to, you could do the picture is worth 1,000 words, you know, kind of do a really beautiful circle like I just did, and then put in the radius and kind of mark it R. But that there's going to be the radius from the center, so it should be this. I'll aim to make it red. So that right there should be the radius from the center to the circle itself. My circle's that bad? It looks like a Pac-Man? Yeah, it is. Okay, diameter. So diameter is the next one. And if you had to, well, diameter, what letter?
D.
Capital, lowercase?
Lowercase?
Yep, lowercase d, because capital D they'll use for density later on, if not now. Diameter is kind of like the what of a circle. Distance across it. So could I say my diameter is going to be this thing here in purple? It has to be the distance across through the center. And that's kind of how you could define it. I think of it kind of like the width of a circle through the center, but kind of get that term down in some way that makes sense. So I'm going to say the width of a circle through, almost made it, through the center. So width of a circle through the center, and you might want to throw a picture on there, a nice perfectly round circle like that, and we could say the diameter then. It's harder than it looks with an iPad, I promise. There we go, that's a little bit more respectable. Yeah, I'll be here all day. Okay, we okay?
I choose you, Pikachu.
We okay so far? There's just a lot of gravity in this iPad environment. The circle gets pulled down a little bit more. How does the diameter relate to the radius?
The
Franklin.
diameter is basically two radiuses connected.
Nice. So we could say D equals, yep, radius times 2. Or I'm going to put the number first to say D equals 2 times R. So diameter should be twice the radius. Or you could go back up to where we talked about the radius and say R equals
D divided by 2?
D divided by 2 or 1/2 times D, kind of either one of those. But those are things that may come in helpful, although a lot of people just kind of seem to know them in their head. So if you wanted to, you could write it D over 2, if you'd prefer. We're going to jump next to circumference, C-I-R-C-U-M-F-E-R-E-N-C-E. Circumference now is going to be a capital C, because the lowercase letter c is reserved for the speed of light. Nice try with the sound. Speed of light goes by Solaris. I think it's like Latin for swift or something like that. Okay, so a capital C for circumference, and it's going to be the distance around a circle. So the distance around a circle. So yesterday we were looking at like rectangles and stuff. There we called the distance around perimeter. So it's kind of like the perimeter of a circle, really. You could look at it that way if you wanted to. Equations for that. C equals, what do you think? Anyone remember this? Pi times D, actually. And D, we said, was what compared to the radius? The D was double the radius. So I really could take that D, and that's the same as 2 times R, right? So another way to write the same equation is going to be, usually they'll put the numbers in front. They'll say 2 pi R. And 2R just kind of replaces the D in that. Should we do a quick example of finding the circumference? I guess it doesn't hurt. The trick to it is just deciding, do I have the radius or do I have the diameter? And then from there you just kind of go. So we'll say find capital C, and if I throw a circle in there, yeah, find C right there, 8. So 8 is the R or the D, radius or diameter? R. So then, since that's the radius, we have to go with the equation on the right. So C equals 2 pi R. And in my perfect little world, you guys all show your work. In reality, you all show your work. Okay, we could then, if you wanted to have an exact answer, do you agree pi is this like ugly irrational decimal? Maybe I should say ugly. It's a beautiful irrational decimal. But do you agree 2 times 8 is 16? So you could just say 16 pi if you want to, and that's like the exact answer. We'll do the number approximation too, but 16 pi is going to be the exact circumference. If you take and punch that into your calculator using your pi key, instead of just 3.14, you get 50.265482. Now I'm going to run out of space before that, so I'll maybe say 2654. Nope, 2655, because I have to round that last digit up. Then I'm out of space. So the question was, what is pi? And you don't have to write this down, but I think pi is officially defined as, if we take this formula here and solve for pi, what do you have to do to get pi by itself?
Isolation.
Yep, and you isolate it. You get rid of the d by dividing.
By putting Emerson in the middle.
So pi equals C, focus people, I know it's a Friday, C divided by d. So I think the official definition of pi is it's the ratio of the circumference to the diameter of a circle. I've heard it defined that way. I don't know if that's insanely helpful, but I've heard it defined that way. So, cool question. Then, next thing is going to be area. And area, capital or lowercase a? Capital, because lowercase a stands for science class.
Area, lowercase a stands for...
Acceleration. Okay.
Oh.
For area, I didn't really write down a definition for area looking at my notes. Basically, it's kind of like if you were to paint the inside of a circle, it's how much paint you'd need. It's kind of that I hate to say space, because that sounds like volume, but it's the area, the surface contained within the circle. So you could write that down if you wanted to, but I'm pretty sure area is like, you've been doing area for a long time. Area is going to be pi r squared. I found a lot of people confuse the equation for circumference and the equation for area. I wouldn't write the circumference equation here, but you'll notice circumference has a 2, a pi, and an r. So does area. That's maybe one way to remember them. They both have a 2, a pi, and an r. The difference is the area is going to be the 2 is an exponent, and the circumference is just multiplied by pi and r. But if we were to quick try to throw an example in here and say find the area, and I'm going to take and draw my circle, and I'm going to put in that there with my center and say that length is 10.
Wait, the thing is totally 10.
Yes, you see my trick. You see my trick. So area is pi r squared. That's going to be the same as pi times 5 squared. Nice. That. What I did is I gave you, hit the wrong button. Gave you that the diameter is 10. So you can't just take 10 and throw it in the equation. Careful, some people say they gave me numbers, you just toss it in without thinking. But instead we have to make this be a 5 squared. And you could, if you wanted to, go back to, we said r is 1/2 of the diameter, or r is d divided by 2. So the radius ends up being 5, because that's half of the 10. So final answer then, you could do one of a couple things. You could say a is going to be 25 pi.
It's about 75.
So that's the exact answer, is the 25 pi. Or you could say 75 point... Oh, no, not 75, 78. Okay. So 78.53, my memory isn't that good. So we'll say 78.5. We okay up to there? And my equals, I'm trying to do those little like squiggly equals for approximately. Now with that, if we knew that the diameter was 10 inches, it'd be 78.5 inches squared. If instead we knew it was 10 meters, this is a ginormous circle, then it'd be 78.5 meters squared. So whatever it is, I'm just going to throw here at the end. And usually I'm more concerned with, can you just get the number answer? And then I let the science teachers, when I was in science, I really beat people up about units. But at least it has to be some sort of units squared. So it's like square meters or square inches or square centimeters. But it's not that it's 78.5 squared. It's that the units, it's like a unit by a unit, that area. Okay, I'm guessing that's all review, yes? So hopefully that's kind of helpful review. The very last two things, I don't know if you've seen these before. So the first one is going to be an inscribed. Does that look at all familiar?
Nope.
Okay. I was guessing that was going to be the new part. This, and I've been trying to come up with, how can I come up with a way of remembering it? Because I struggle with things like this. Which one's inscribed and which one's circumscribed? The inscribed is the object is in the circle. And the in is kind of like that inscribed. Or probably a more official definition is like the vertices of an object are on the circle. So vertices. Vertices is just plural for vertex, kind of the corners of a polygon. Vertices on the circle. So we'll see how this goes. You've seen my other drawings. But if I have a circle, and nice beautiful circle that thing is, this here would be a triangle that's inscribed in the circle. And it could be a pentagon inside there or a hexagon. But if I did it right, my vertices, my corners, should be lying right on the circle itself. So that would be an inscribed triangle. Is that fair? Any shape in there. Or any shape, any polygon could be inscribed inside a circle. So now the other one is going to be circumscribed. So we'll say circumscribed, C-I-R-C-U-M-S-C-R-I-B-E-D. Circumscribed, and when I did the inscribed, I started with the object, so object in the circle. So now I need to start with the same thing. It's going to be the object, whether that be a triangle or a hexagon or whatever. Object, I'm going to say surrounding, and I'm going to spell it wrong for a point, because I have this sur for circumscribed. I'm going to say surrounding, C-I-R-R-O-U-N-D-I-N-G, surrounding the circle. And I know that's kind of lame and childish, but I was looking at the notes thinking, how in the world am I going to remember this? So if you ask me a question in class, I can sound really smart. What you're going to end up with is you're going to have the midpoints on the circle. So midpoints of the object on the circle. I'm going to leave off that of the object. But now for this, I'm going to start with my circle and see if I'm better drawing it that way. So now if I try to draw a triangle again, the midpoint of this line segment should just touch the circle. Ooh. If I make really big dots, that'll help. So, for a better example, see your book. But you kind of get the general idea, even though my picture leaves some to be desired. Awesome. That's it for today.